Welcome to this video on simplifying rational expressions. And recall that a rational expression, right, is a fraction where the numerator and denominator are both polynomials. So a ratio of two polynomials. And when we talk about simplifying a rational expression, it's just like simplifying a fraction, right? You're trying to rewrite it so that the numerator and denominator have no common factor. Okay, so let's begin. So my first example, I'm asked to simplify the rational expression 3n squared plus 12n, all that in the numerator divided by, and then the denominator 6n. Alright, before I get into this, I want to point out a very common error that is made. So off to the side here, I'm going to put, don't don't do this. If very often people do this, I have 3n squared plus 12n and then being divided by 6n, and people will very often say, hey, 6n goes into 12n twice, right? 12 divided by 6 is 2, and then the n's cancel, so they cancel the n's and they say, hey, 6 goes into 12 twice, and then make this just 3n squared plus 2. That's no good, okay? And if you want to check, they might say this is again 3n squared plus 2. If you want to double check, if you're saying these are equal, check with some numbers. So suppose I let n be equal to 1, then the numerator would be 3 times 1 squared plus 12 times 1, so 3 plus 12, or 15, divided by, and the denominator would be 6 times 1, which would be 6. I get 15/6, which if you were to reduce this, right, this is 3 times 5, this is 3 times 2, the 3 is a common factor that would cancel. You'd be left with 5 halves, or 2.5. This is 2.5 when n equals 1. But over on this side, when n equals 1, you do 3 times 1 squared, which is just 3 times 1 plus 2, you get 5. And these are clearly not the same number, right? But, so if you're saying, hey, these are equal, I can just cancel these here and say that it's 3n squared plus 2, you're not getting the same value for every single value you replace n with. And in order for two expressions to be equal, they must have the same value for no matter what you plug in for the variables. Alright, so my big note here, my big takeaway is do not cancel common terms. Right? This positive 12n, right, that's a term of the numerator polynomial. 6n is a term of the denominator polynomial, and you're like, oh, cancel some of these n and n. You can't cancel common terms. You can only cancel common factors. I'll write that big note right here. You may only cancel can't spell. Cancel common factors. Okay, only factors, only parts of a multiplication, only parts of a product. Right, terms are parts of a sum. Right, there's plus there, and they're separated by the plus sign. Do not cancel common terms. Only cancel common factors. Right, if it's part of a multiplication, if this were 3n squared times 12n, then I could do this and have 3n squared times 2. But the plus there makes it incorrect to do that. Alright, so back to my problem. And you got this, don't cancel common terms, only cancel common factors. Alright, so how we go about this? So the first thing is to factor the numerator and denominator completely. Alright, I'm looking for common factors to cancel. So it would be nice if I knew what the factors of the numerator and denominator were. So factor numerator and denominator completely. And I've put up several videos, and again you can find others that are probably a bit better than mine, but of factoring polynomials completely. Alright, so the numerator, 3n squared plus 12n, they have a greatest common factor of 3n. Right, so the numerator, I'd pull out a 3 times n, 3n, there's the GCF. And when I pull 3n out of the numerator, what am I left with is n plus 4. And then, that's as factored as the numerator can get. And the denominator, 6 times n, it's a single term, so can't really factor it any further. I guess I could factor the coefficient of 6 more. 6 is 2 times 3, so this is like 2 times 3n, right? 2 times 3 times n is 6n. So if you'd like to do that, take even the coefficient factors down to primes, nothing wrong with that. And then look, you see I am now seeing a common factor. In fact, I see a couple. They both have a factor of 3, right? And a factor of n. So you cancel those, or they become 1 if you want. You're removing ones. Anything over itself, anything divided by itself is 1. You can think of it that way. And so what I'm left with now is, this was equal to this, and this is equal to. And now look at the numerator. I'm left with just the factor of n plus 4. Now you can keep it in parentheses if you want, but since there are no other factors now, right, I removed all the other ones, I'm just going to not put parentheses. All that in the numerator divided by, and then the only factor remaining in the denominator is 2. Okay, and there we have it. Now, one thing I have to point out. Remember, I said this earlier, that two expressions are only equal if they're always the same value, whatever you plug in. Alright, so stating this, right, we started off with 3n squared plus 12n over 6n, and we're saying that that's equal to n plus 4 all over 2, or divided by 2, based on the previous page. This is not always the case, right? Now if n was, we could say if n was 1, we'd get the 5 halves, right? We did that earlier. When n is 1, this is 5 over, 5 halves when you reduce it, 15 over 6, or 5 over 2. And this would be 5 over 2 when n is 1. They're the same value. And you can try all sorts of values for n, and they'll be equal. But there's one value in particular where they're not, and that's when n is 0. So I'm going to put off to the side here, n cannot be 0. Alright, and I also put up a video of this earlier, and you can check it out if you want. Remember, denominators can't be 0. Right? So this 6n can't be 0. Right? You'll have an undefined operation. So you think, when is 6 times n equal to 0? Well, that's when n equals 0. So n can't be 0. n equals 0 makes this undefined. Right? And you can check that out. Right? When I plug in 0, this side, this expression is undefined, but this expression is 0 plus 4 divided by 2. So what I'm getting here, when n equals 0, we get an undefined expression on the left side being equal to 0 plus 4 divided by 2, which is 2, right? 4 divided by 2. How can something that doesn't have a value be equal to 2? Right, so this is wrong. Right. So very often when you see expression, a fraction written as equivalent to another fraction like this, you will also see either a little comma or a semicolon, and then off to the side, values that they won't be equal for. Right? These will be equal for any value of n except 0. All right, so just keep that in mind, that the fact that denominators cannot be 0, and I will point out values that make denominators 0, make things undefined as we go through. All right, so that was my first example. Got plenty more. All right, next one, another rational expression, another fraction with two polynomials. I'm asked to simplify 2z squared plus 6z plus 4 in the numerator divided by negative 4z minus 8 in the denominator. Again, please do not cancel stuff like this. Oh, z cancels with z, and negative 4 with positive, the 4s would cancel. Don't do that. These are terms of a sum, terms of the polynomial, not factors. They're not. This isn't multiplication here. All right, these aren't parts of products, so you cannot cancel things right just yet. All right, so first, I'm going to factor the numerator and the denominator completely. The numerator, I'm noticing, has a GCF of 2, right? Every single one of those terms has a 2 as a common factor. And when I remove 2, you'd have z squared plus 3z plus 2 left over. So I think we can go a little further with that. We'll factor that more. In the denominator, this polynomial has a lead coefficient that's negative. So what I like to do when the lead is negative is pull out the opposite or negative of the GCF. The greatest common factor is 4, but again I'm going to pull out a negative 4. Alright, so negative 4 comes out, and what would be left over would be z plus 2. Okay. So the numerator is factored a little bit, not completely though. We can take z squared plus 3z plus 2 down further, and this can factor a little more if you want. If you want to say 4 is 2 times 2, so I'll do that here. So in the numerator, I've got 2 times, and then z squared plus 3z plus 2 would factor to z plus 2 times z plus 1. All right, so here's all the factors of the numerator, these three things, 2, z plus 2, and z plus 1. And then in the denominator I have negative, negative 2 times 2, or if you want to write, the opposite of 2 squared, whatever you want for negative 4, that's fine, times z plus 2. All right. Now off to the side, I'm going to make a note to myself. Remember, the denominators can't be 0. So just look at the denominator here. There's negative 4 times z plus 2. That can't be 0. So that means that z cannot be negative 2, right? Because if z took on a value of negative 2, we'd be dividing by 0. But any other value is fine, right? So as long as z is not negative 2, we can continue and simplify, and we won't be dividing by 0. All right, so working further, I'm noticing some common factors here. There's a 2 up here, a factor, and there's a 2 down here, leaving 1, 2 left in the denominator. And there's a factor of z plus 2 in the numerator, and a factor of z plus 2 in the denominator. All right, so when all's said and done, I've got just z plus 1 in the numerator. That's the only factor left. And the only factor left in the denominator is negative 2. Now typically it's just a standard not to put a negative number and a negative lead in the denominator like this. So you could do this you could rewrite this in a couple ways, where you move this to like the middle, right in line with the fraction bar. So this is negative, and then z plus 1 in the numerator, and then 2, just 2 in the denominator. Or you could also transfer it to the numerator and make it the opposite of, but just make sure that you're doing the opposite of the entire numerator. So in parentheses, z plus 1 all over 2 like that. So you can have the negative sign in the denominator and the numerator, or just kind of straddling in the middle. And they all mean the same thing. All right. But I personally prefer this one right here. Okay, so when all said and done now, we got this, 2z squared plus 6z plus 4, divided by negative 4z minus 8 is equal to the opposite of z plus 1 divided by 2, as long as z is not negative 2, right? We stated that earlier. Okay, so as long as z is not negative 2, this is a true statement. And you can go ahead and check it out, test it out, plug in some values other than negative 2 for z. So an easy one here would be 0. What if z were 0? Well, then this side you'd have 0 plus 0 plus 4, so 4, divided by, and then 0 minus 8, or negative 8. 4 divided by negative 8. That would reduce to negative 4/8, or negative 1/2. And then look what I have over here. When z is 0 over here, 0 plus 1 in the numerator, that's 1/2, and then the opposite of that. So I get negative 1/2 equals negative 1/2. It checks out. And that would be the case for any value of z other than negative 2. And go ahead and try it. Plug in 3, 5, a third, 15, plug in whatever you want for z, as long as it's not negative 2. And you will see that indeed these two expressions have the same value. All right, so I'm going to continue on. Here is yet another example. So here I have two, degree 2 polynomials. I'm asked to simplify the fraction, simplify the rational expression. And one more time I'm going to state, do not cancel. I see, there's negative 28 here and negative 28 here. So I'm just going to get rid of those. But those are not factors. Those are terms. Those are parts. This is 3a plus negative 28, a plus negative 28. All right. You can't cancel things the way this looks right now. And even if you did, if you cancel the 28s and the a's and the a squareds, if you decide to do the wrong thing, you can always double check at the end by plugging in different values of a and seeing if you got the same numbers. All right, because again, if you're writing an equal expression, they should represent the same value no matter what you plug in for the variable, right, as long as you're not dividing by 0. All right, so I'm going to first factor the numerator and denominator. Now I'm going to kind of do this out loud and write down the result. Again, if you want to look at, I've put up videos on factoring quadratics, right, degree 2 polynomials before. If you want to look for those or find other people's videos out there that are better, or read your book. So a squared plus 3a minus 28. That'll factor to a in one factor, a in the other. And remember, I'm just looking for factors of negative 28 that add up to positive 3. Okay, so positive 7 and negative 4. A plus 7 times a minus 4 is how the numerator factors. And the denominator, again, I'll break that up. You got 2a in one, 1a in the other to give me the 2a squared. And then again, I'd be looking for factors of negative 28, so that when I FOIL, I get minus 1a in the middle. All right. So that'd be a minus 4 here and plus 7 here, and you can double check that. Right, here's negative 8a plus 7a would be minus 1a. Okay, so works out. Now, before I do any simplifying, before I say, hey, this expression is equal to this one, I want to make sure I'm also plugging in the right values of a when I check. So look at the denominator, right? Again, the denominator can't be 0. So a cannot be, 4, right? That would make this factor 0. And at the same time, a cannot be, if you set 2a plus 7 equals 0, a would be negative 7 halves, right? You would subtract 7 and divide by 2. So these are some values I cannot use for a, right, if I were to plug something in for a. Because if I plug in 4 for a or negative 3.5, negative 7 halves for a, I'd be dividing by 0, and that's no good. That's undefined. So now that I've pointed that out, as long as a is not one of these values, I can simplify. And I'm seeing the common factor of a minus 4 in the numerator and denominator. Okay, so this a squared plus 3a minus 28 divided by 2a squared minus 8 minus 28 minus a minus 28 is equal to a plus 7. And again, since it's the only factor left, no need for parentheses around it. Divided by, and then 2a plus 7. And again, it's the only factor left in the denominator, so I'm not going to put parentheses around it. It wouldn't be wrong to put parentheses around it. It's just unnecessary. As long as a is not 4 and a is not negative 7 halves, right? As long as a is not one of those two numbers, this is true. These are equal. Okay. And again, you can check with a couple values if you want. I'll actually write this time. Now, one of the easy ones would be, what if a was 0, right? 0 is not one of these. This, you'd have negative 28 divided by negative 28. That's positive 1. And then this expression, you'd have 7 divided by 7. That's positive 1 again. So they are indeed the same when a is 0. But they should be the same as long as a is not one of these. So how about another one real quick? When a is 1, the numerator on the left side, you'd have 1 squared 1 plus 3 times 1 is 3 minus 28 divided by, and then 2 times 1 squared is 2, and then minus 1, and then minus 28. So on the left side, you'd have 4 minus 28, negative 24 in the numerator, and then 2, and then minus 29, be negative 27 in the denominator. And this would be a positive number, right? Negative divided by negative, and if you want to simplify it further, 24 is 3 times 8. This is 3 times 9. So this is 8/9. That's the left. That's this expression here. Now let's try this one. If a is 1, you have 1 plus 7 in the numerator, right? 1 plus 7 divided by, and then 2 times 1 plus 7, which would be 2 plus 7 in the denominator. And look at that, 8/9 again. 8 in the numerator, 9 in the denominator. You get the same value each time. And again, that should happen as long as a is not 4 or not, and at the same time not negative 3.5. Try it out with some other number if you want. All right. So another example, this time where we have a degree 3 polynomial. All right. And remember these degree 3s with 4 terms, you can try to factor those by grouping. Which again, I'm not going to go through in this video. Right, I have had separate videos out factoring by grouping. You can look those up or find other videos. Look in your book. All right. So again, I'm trying to simplify. Z cubed plus z squared minus 3z minus 3. All that in the numerator divided by z squared minus z minus 2. And please do not cancel these z squares. Do not cancel the z's. They are not factors, they are terms. You can only cancel common factors when simplifying a fraction. Alright, so if you factor the numerator, alright, again, remember how grouping works. I'm not going to write it out, but just, I'd have these two terms in a group plus, and then these two terms in a group. I'd factor z squared from these two, giving me z squared times z plus 1. And here I'd factor negative 3 out of these two, giving me negative 3 times z plus 1. So then they have the common factor of z plus 1 come out, and then what would be left over would be z squared plus negative 3, or z squared minus 3. And that would be as factored as it can get, because z squared minus 3, that's not a difference of squares or anything. That cannot be factored over the integers more completely. So I'm done with the numerator. The denominator is another quadratic. Lead coefficient's 1, so it makes it easy to factor if it is factorable, and it should be. Alright, so I got z and z, and then I'm looking for factors of negative 2 that add to negative 1. That'd be negative 2 and positive 1. Okay. And then once the denominator is factored, again, I can very easily see that the value of z I use when I plug in stuff can't be 2, and the value of z cannot be negative 1, pardon me. Because if I let z be 2, I'll be dividing by 0. And if I let z be negative 1, I'll also be dividing by 0. So these make my expression undefined. I don't like those. Those are no good. Alright, so now that I've pointed that out, as long as z is not one of these numbers, then I can continue and simplify. Alright, z plus 1, I'm seeing a factor of z plus 1 in both the numerator and denominator. And so this fraction here simplifies to z squared minus 3 in the numerator, and again, it's the only factor left up there, so I don't really need parentheses around it. Divided by, and then again, the only factor left in the denominator is z minus 2, and that's it. And again, this fraction is equal to this fraction as long as z is not 2, and as long as z is not negative 1 either. All right. Okay, so try anything else besides these two. Right? Try, obviously 0 would be good, right? You'd have negative 3 over negative 2. Same thing here, negative 3 over negative 2. You positive 3 halves for both. Plug in 1, plug in 5, plug in 10, plug in a million, a billion, a Google, a third, a fifth, a tenth, whatever you want, negative 8. And these should be the same value. And you can check that out on your own. But there we go. Wonderful. All right, so another example. Again, just kind of hammering this home. All right, so again, some pretty easily factorable quadratics here. So the numerator, this is one of those perfect square trinomials. This actually factors to 2k plus 1. Now you can write 2k plus 1 times 2k plus 1. There's nothing wrong with that. It's just typically people would write that as 2k plus 1 squared. Right? Just, so you don't have to write the same factor twice, but it is the same factor times itself. Divided by, and then 4k squared minus 1 is one of those difference of two squares. That would factor to 2k plus 1 times 2k minus 1, and you can double check. Alright, so and yeah, and then from here again, when the denominator is factored completely, it's very easy to see. If I look at the denominator there, I can see that when I plug in values for k, right, k cannot be negative 1/2, and it can't be positive 1/2 either. Alright, I might even just put these together and say k can't be plus or minus 1/2, which I'll do over here with a little plus or minus symbol. But you see, if k were negative 1/2, this factor would be 0, and I'd be dividing by 0. And if k were positive 1/2, this factor would be 0, and I'd be dividing by 0. Now for the common factor. Now if you left it this way, I'm seeing 2k plus 1 in the numerator, a factor of 2k plus 1 in the denominator. If you wrote it this way, remember this number, this exponent, means that there are two of these. So I see a 2k plus 1 in the denominator, and then I'm just getting rid of one of those, so I change the power from 2 to 1. All right. Either way, what's left is, well, there's only one factor in the numerator, 2k plus 1. And there's only one factor in the denominator, 2k minus 1. So this fraction will be equal to this fraction for any value of k as long as k is not positive or negative 1/2. Right. But for anything else, right, plug in 0, plug in 5/3, plug in 1,000,000, right? These two fractions will have the same value, and you can double check that. All right. Now my last few examples here have some. So far, all my polynomials have been written in what they call descending order, where your highest power of the variable is first, then the next highest power, k squared, k to the first, and then none of it. All right, all my polynomials so far have been in what they call descending order. So here's a weird one, okay, where we're asked again to simplify the fraction, get rid of any common factors that the numerator and denominator have. But this one has, also this one has two variables, right? I haven't seen anything with two variables yet. So if I were you, little tip, okay? If I was asked to, like I am now, simplify a fraction, simplify a rational expression with multiple variables like this, there's a and b, right? 7a minus 7b divided by b minus a. Again, don't just cancel the a's and cancel the b's, please. These are terms, not factors. I would write, I'm going to write all my polynomials, can't spell again, all my polynomials in descending order. Right, so highest powered term first, and then keep going down. With respect to the same variable. Right, so here, what I mean by this is, there's A's and B's. So like this one up top in the numerator is descending in term with A's, right? You have A to the first, then no A. This one is descending with B's, right? You have B to the first and then no B. So that's inconsistent to me. I personally don't like that. So what I'm going to do is just rewrite. I'm going to take this tip here and do that here. All right, we're not factoring yet. Just rewriting each polynomial so that it's descending in the same variable. So the numerator I'm going to keep 7a minus 7b, right? So that's descending with a, right? You have a to the first, then a to the nothing, right? No a. It's the denominator I'm going to rewrite, right? Right now it's just descending with b's. I would like to put the a's, have it descending with a's. So I'm going to put the a term first, so negative a first, and then you have the positive b term, plus b. And that's descending in terms of a. So now all my polynomials are descending with respect to the same variable. I hope that's clear. I hope that makes sense. And then I'll go and factor and reduce and stuff. Okay. So now here comes the factoring part. Numerator. The greatest common factor of these terms is 7. Right. So I'm going to pull 7 out. And what's left over when I remove 7 is a minus b. And then in the denominator, this is my lead coefficient here is negative. If you look at these, the greatest common factor would be 1, but my lead is negative. And I've mentioned this before. When the lead is negative, the way I have it written, I'm going to pull out the opposite of the greatest common factor. So I'm going to actually pull out a negative 1 from this polynomial down here. When I remove negative 1, what's left over? Negative 1 times a would be negative a, and then negative 1 times negative b would be positive b. And so I have a minus b left over. And then, as I've done with previous examples, once the denominator is factored completely, you can state what you can't use. Now, here there are multiple variables, so I can simply say that this a minus b factor can't be 0, right? Or if you add b to both sides of this, a cannot be equal to b. As long as a is not equal to b, you're going to get the same expression back. You're okay with the canceling here. All right. So as long as a is not b, right? As long as I use like 4 for A and 5 for B, or 2 for A and 7 for B, whatever. As long as A and B aren't the same value, I won't be dividing by 0, and I can cancel these common factors here. They both have a minus B. And then what I'm left with is 7 in the numerator divided by negative 1 in the denominator. That's just negative 7, right? Positive 7 divided by negative 1. So this expression here is always going to be equal to negative 7 as long as the value of A is not the same as the value of B. And if you'd like to test that, right, let's check it out. When A is 2, and so suppose let's let A be 2 and B be 5. Right, again, as long as they're not the same, right? Because if these were the same, see, I'd be dividing by 0. You can't do that. But if A is 2 and B is 5, let's see. You have 7 times 2, 14. Minus, 7 times 5, that's minus 35 in the numerator. Divided by, and then B minus A would be 5 minus 2. And you see up top here, I'm getting negative 21 divided by positive 3. That is indeed negative 7. And you can try this out with all sorts of A's and B's, as long as they're not the same value. Okay, I know I've said that several times now, but just to hammer it home, right? Just make sure you're not dividing by 0 ever. Okay, so here's another example where the polynomials aren't in the way I would like. I would actually prefer things to be in descending order with respect to a variable. So here's one where I'm saying, again, simplify the following rational expression. 12 minus 4x divided by 4x squared minus 13x plus 3. Notice my denominator is in descending order with respect to x, right? You have x squared, then x to the first, then 3. So I'm going to leave that the way it is before I factor. It's the numerator that's not in descending order with respect to x. So I'm going to put the x term first, right? So negative 4x first, and then the positive 12, right? That's a positive result. So that's the same thing as negative 4x plus 12. And then I'll do the factoring. Right, so here comes the factoring part. In the numerator, right, the greatest common factor is 4, but as I've said before, my lead coefficient is negative. So instead of pulling out 4, I'm going to actually pull out negative 4. And when I remove negative 4 from the numerator, the other factor would be x minus 3. Alright, and if you'd like to break down 4 even further, go ahead, make that 2 times 2, the opposite of 2 times 2. But I'll leave it that way for now. And then the denominator is quadratic. No, the GCF is 1. And again, I'm just going to really quickly break this down. And I'll tell you right now, this will be 4x here times x there to give me the 4x squared. And then I would need to get negative 13x minus 3 here and minus 1 here. Right? You can check this out. This would be minus 12x minus 1x minus 13x, and then negative 1 times negative 3 is positive 3. So this is going to give me that back. All right, and then after I have factored the denominator, again I look at the denominator and I say, what makes the denominator 0? What makes this expression undefined? So I'm seeing here that x cannot be a fourth, right? That would make this factor 0, and x cannot be 3, right? Because that would make that factor 0. And so as long as I'm not plugging in one of these numbers, I'm okay. I can reduce this. I can cancel these common factors of x minus 3. All right. So finally, this fraction I started with is equal to negative 4 left over in the numerator divided by, and then 4x minus 1, the only factor left in the denominator, as long as x is not 1/4 and not 3, we're okay. Okay, so I'm going to again put that over here. And check it out, right? Again, try any number other than these two, plug them in here, plug them in here, and these should be the same value. Try it with 0, 1, 5, 10 billion, a third, whatever. Just so long as it's not a fourth or 3, you should be good. These should be the same. All right, and I have one final example we're again doing something similar to this one here. Factor, let's simplify this fraction. 25z squared minus 1 divided by, and then 3 minus 15z. Again, please do not cancel z's right now. These are all terms of a sum, not factors. You can only cancel common factors. Alright, so as before, this, I like things in descending order. Just it looks nice, it makes things easier for you in the long run. So this one is, descending in z, right? So I'll keep that the way it is. You got 25z squared minus 1 in the numerator. The denominator is not descending in z though. Alright, so it's z to the 0 and then z to the first. It's ascending, not descending. So I'm going to rearrange it. Put this negative 15z term first, and then the positive 3 term second. So that's the same thing as negative 15z plus 3. And then here comes the factoring part. The numerator is a difference of 2 squares. You would actually factor that to 5z plus 1 times 5z minus 1, and you can double check by multiplying. You'll get 25z squared minus 1 back. Then divided by, and then again the greatest common factor down in the denominator. The greatest common factor is 3, but the lead coefficient's negative. So I'm going to pull out negative 3. And when I remove a factor of negative 3 from the denominator, there'd be 5z minus 1 left over. And you can double check, multiply, you get negative 15z plus 3 back. Alright, and then as with all the other examples, after I have factored the denominator, I can very easily tell you what values of z I cannot use. Well, z cannot be 1/5 here. Right? That would make this denominator 0. Right, this 5z minus 1, if set it equal to 0, add 1 divided by 5. Z cannot be 1/5. But if z were anything else, anything other than 1/5, we're golden. We can continue. And we can cancel. The 5z minus 1 is a common factor in both the numerator and denominator. And then I'm done. Right, this is equal to 5z plus 1 in the numerator divided by, and then negative 3 in the denominator. Again, as long as z is not 1/5, and I mentioned before, you can write this a few ways. If you don't like having a negative number in the denominator, like I don't, we can just kind of shift this around. You can either leave it here or put it in the middle, in line with the fraction bar, like this. These are the same thing. So I can have 5z plus 1 divided by negative 3, or the opposite of 5z plus 1 divided by 3, or put the negative in the numerator, but just make sure that you're doing it's the opposite of the entire numerator. You can write it that way as well. Again, I prefer this second way. Alright, so I'm going to say that this 25z squared minus 1 divided by 3 minus 15z simplifies to the opposite of 5z plus 1 divided by 3, and again they're only going to be equal as long as z is not 1/5. Alright, anything else should be fine, and check it out. Let me just do it with one real quick out loud. How about when z is 1? When z is 1, this would be 24, right? 25 minus 1, 24 divided by negative 12, right? 3 minus 15. And 24 divided by negative 12 would be negative 2. Right? So you get negative 2 when you plug in 1 up here. We'll plug in 1 here. 5 times 1 plus 1 is 6. 6 divided by 3 is 2. And then the opposite of that is indeed negative 2. You get negative 2 and negative 2. And try it out with all sorts of other numbers. As long as they're not 1/5, these fractions should be the same value. Okay, so there's plenty of examples there on simplifying fractions, simplifying rational expressions. And as always, I like to say, please try to understand this stuff on your own first. Read through it in a text, work out the author's examples, try to get things on your own, and I feel like it sticks better that way. And you practice problems and check your answers in the backs of books or what have you. And even and don't give up after the first try. Right? Many people get frustrated too easily, too quickly. If after several attempts on some problems you're still not cutting it, still not getting it, go back and read the section again. Maybe it'll click the next time through. And if after you do that a couple times it's still not clicking, well then there is no sign of weakness whatsoever to go looking for help. That is the reason certain people are around, like asking your teachers, your tutors, some friends, look for videos on the topic such as this one, or plenty of other ones out there that are better than this one, trust me. And just stay persistent, keep at it, and I know you can do it, and try to have fun with it. Thank you.